The next thing I want to talk about are strings, and strings are actually arrays and very similar to byte arrays. Now, if that sounds a little bit too complicated, let me break it down for you. So that's somehow also very unique to Solidity. In strings, there are no string manipulation functions whatsoever, except of one, that is you can concatenate strings, you can merge them together. But natively, there are no string manipulation functions. There are a couple of libraries that help you with that, but there is not even a native string comparison possible. You can use the Kazak hash of two strings and then compare this one, but there is basically nothing there to let you really work well with strings. And the reason for that is strings are extremely expensive to store on a blockchain. Now let's get started with an example. I'm going to open up our contracts folder again. Let's call this example strings sol, and let me copy over the SPDX license identifier and pragma line, and then contract example strings. And let's simply define a string public. My string is hello world. We had this at the beginning of our course already. If you're going to run this, then you can see hello world. And now let's write a setter function for it. Function set my string. And over here, you already see a difference to the others. Before we just had the type, and then we had the variable name. But if we are going to do it like this, then the compiler will error out and tell us, hey, data location must be memory or call data for parameter in function, but none was given. So we can maybe place this parameter inside our memory location. Memory is an ephemeral data location to work within functions or just during the transaction. The memory location will be gone after the transaction is finished. So in order to make this permanent, to make this stick, we have to bring it over to a storage location, which is where storage variables are stored at. So let's just define this. Let's override our storage variable, redeploy this, and it's hello world. And now it's ASDF, the string that I entered. Now, in order to compare two strings, and let's just say we are giving a string memory my string, and then we want to know if this string is the same as our string that is already stored. And in this case, we are doing something that you have not learned, but just follow along. We are not making this only public. We are making this a public view function, meaning it is a reading function and it can actually return something. And we are going to return a Boolean over here. Booleans you have already learned can only be true or false. And what we are going to return is if my string, the storage variable, is the same as my string, the memory variable. And normally you would say return my string is equals my string. But our compiler doesn't like that because of something that actually doesn't make any sense. Returns. Okay, now it went to the right location. So it says the operator equals is not compatible with type string, storage ref, and string memory. What can we do here? So the thing is, there is no native comparison. You have to use the Kazak 256 hash of this one and the Kazak 256 hash of that one. And because the Kazak 256 hash function actually requires a single bytes argument, you also have to abi.encode pact this one, and abi back that one, and then it should work. So then we can actually do a string comparison. So right now our string is hello world. And if you want to compare this to hello Goofy, then it will return false. But if you return hello world, let's hope it returns true. Yes, it returns true. So now we're actually not comparing the strings. We are comparing the hashes of the strings. Now, there is also a difference between strings and bytes. We can very well say bytes public, my bytes is hello world. And if we are going to deploy this one, it will return us the bytes representation of this string. But there's not only that difference. You can technically strings are just the same as bytes, and there's a major difference. Number one is with bytes they have a length, so I can say my bytes dot length, and I will get back the length of these bytes, and I can also convert them. But with strings you cannot convert every string into bytes and then get the length, because strings are represented in UTF-8 while bytes are not. That means that sometimes a character is represented by 2 bytes and sometimes by 1 byte. So if you just access the low-level representation over here, then you always get 1 byte. And you maybe, if you have UTF-8 characters, I think like the umlaut, the German umlaut, or specific emojis and so on, they all need 2 bytes to represent the actual character, so you would get the wrong length, and it's actually very hard to calculate this back. So this is why in general it is not very advisable to use strings in smart contracts, but for our project we are still working with strings, and I think that's then pretty much the last time, unless it's something like symbol names for tokens. With that being said, off to the next lecture.